Let's continue practicing SOHCAHTOA in question number 6. We have a right triangle and we're trying to find x. Now this is Pythagorean theorem. We know that x squared plus 1 squared is equals to the hypotenuse 2 squared. X squared is equals to 2 squared, which is 4, minus 1 squared, which is just 4 minus 1. So we have x squared equals 3, and thus x is equals to root 3. How do you find theta? Well, we can use SOHCAHTOA. Let's try using opposite and hypotenuse. Sine theta is equals to opposite over hypotenuse. And we remember from previous question that theta is simply sine inverse of that number. So we have 30 degrees. Now what's sine of this angle? Sine 60, we stick our finger here, is opposite over hypotenuse. Recall SOHCAHTOA. SOHCAHTOA, the trig ratio sine is opposite over hypotenuse. So sine 60 is equals to opposite, which is x, over the hypotenuse, 2. And we solved from the previous question that x is root 3. So the answer is root 3 over 2. Let's continue with question 7. Find sine theta. We stick our finger here. Sine is opposite over hypotenuse. It's good to memorize the Pythagorean triples. 5, 12, 13. C squared equals a squared plus b squared. Memorize 3, 4, 5, 5, 12, 13. These are very frequent Pythagorean triples. So sine theta is opposite over hypotenuse. We have 5 over 13. What is cos theta? Cos theta is adjacent over hypotenuse. So we have adjacent, which is 12, over hypotenuse, 13. What about tan? Tan is opposite over adjacent. Opposite over adjacent, 5 over 12. Find sine alpha. We're now dealing with this angle up here, so make sure you move your finger here. Sine is, the new opposite is 12 now, opposite over hypotenuse. Cos alpha. Cos is adjacent over hypotenuse, 5 over 13. And tan alpha is opposite over adjacent. Now finally, let's find alpha using two different trig ratios. Let's use sine and cos. So alpha, using this result here, is sine inverse of this fraction, 12 over 13. Or you could say the same answer is, using this result here, cos inverse of 5 over 13. And if you really want to show off, you can use a third method. We can even use tan inverse of this result here. And all the angles are the same. Alpha is approximately, using your calculator, 67.4 degrees. Let's try one more classic problem. What's the height of the tree? We're going to use SOHCAHTOA to find h. SOHCAHTOA. Your eye is here, and we'll say that you are 2 meters tall. You're very tall. You're standing 10 meters away, and you're looking up an angle of elevation of 40 degrees. So the question is, what is x? X happens to be from here to here, just the triangle part only. If you know what x is, x plus your height, 2, would be the height that we're looking for. So h equals x plus 2. So if you really focus on the triangle, the right triangle, we can use SOHCAHTOA to solve for x. We slide the 10 meters up here, and let's really focus opposite and adjacent. opposite adjacent. So using SOHCAHTOA, we know that tan of 40 degrees is equals to the opposite, which is x over 10. Using basic algebra, multiply both sides by 10, we have x is equals to 10 tan 40. And this is just a number. So the exact answer would be 10 tan 40 plus 2. If you really want to get an approximate answer, just use your calculator in degree mode. So using my calculator, I have x equals 8.39 meters, but we know that we're not going to forget to add 2 to the original height. So finally, h is going to be this result plus 2, which is 10.39 meters. It's amazing that we can find the height of a tree without even using a ruler or climbing the tree.